Welcome to Lesson Up, math tips, tricks, and other ideas. To help continue expanding this site, don't forget to subscribe and like. One of my students wanted to determine the probability that, in a World Series between two evenly matched ball teams, her favorite team wins the series in 4 games. If you'd like to try this problem on your own, you should pause this video now. Now, the Major League Baseball World Series is a best-of-7 games playoff. Therefore, the first team to win 4 games wins the World Series. The student approached the problem as if it was a coin toss. She decided to take on the task of listing all possible sequences of tossing a coin 7 times, letting a head represent a win and a tail represent a loss. With 2 possible outcomes per toss, she correctly calculated 2 to the 7th power, which is 128 possible sequences. After listing all the sequences, she realized that a win for one team is a loss for the other. In other words, half the sequences were reflections of the other half. Nonetheless, she was only concerned with winning results for her team. So she then highlighted only the outcomes that had 4 wins, since that is what's needed to win the World Series. She tallied 35 different ways in which the World Series could be won. Since there is only one sequence in which the first 4 games are wins, she theorized that there is a 1 out of 35, or about a 2.86% probability of her team winning the World Series in 4 games. When she showed me her work, I mentioned I was very impressed with her effort. However, I stated in her work many of the sequences contained members that shouldn't be included. Immediately, I pointed out that the outcome that contains the first 4 wins should not contain the last 3 losses, because the series is over by then. Sincerely, she quickly adjusted the outcomes, removing any members after a 4th win, and relisted the sequences. However, still showing 35 outcomes of winning the World Series, again, she argued that the probability had to be 1 out of 35. Well, without a doubt, it's inspiring to see a student challenging themselves to formulate an understanding of a problem like this. Her approach was impeccable, but her reasoning, well, it had its flaws. Nonetheless, these are the perfect opportunities to direct students to check their approach. I assured her that the probability could only be 1 out of 35 if each sequence was equally likely to occur. Easily, we can see that there are far more outcomes for winning the series in 7 games than winning it in 4. Reverting back to her coin toss analogy, she realized that any flip, or in this scenario a win, is independent of any other. She asked herself, if she flipped a coin 4 times, what would be the chance of flipping all heads? Her correct response was 0.5 to the 4th power, which of course is 6.25% probability. Simply applying this to the World Series, and she had her result. But unhappy with her understanding, I challenged her with a revised scenario. Determine the probability that, in a World Series between 2 evenly matched ball teams, her favorite team wins the series in at least 5 games. Again, if you'd like to try this problem on your own, you should pause this video now. Recognizing that this is the complement to winning the series in 4 games, the student simply subtracted her results from 1, resulting in a 93.75% probability. I asked her if she knew how to check her answer. She realized that to determine the probability of winning the series in 5, 6, or 7 games can be calculated the same way she correctly determined winning the series in 4 games. Then simply tallying up these probabilities should result in the same solution. Obviously, the student could see that there is a 50% difference between the 2 totals. Why the disparity? Again, reverting back to her coin toss model, the student recognized that she only included the sequences with winning outcomes for her team, thus removing half of the sequences from her calculation. Therefore, For the complement, she needed to subtract her 4-game winning from 0.5 rather than 1. Of course, winning outcomes for the other team result in losing outcomes for her team. Because she was only interested in her team winning the World Series, she removed 50% of the results. So it's good to check our work and make sure to have a clear understanding of what's occurring. She rightfully concluded that for a particular team, such as her favorite team, to win the World Series in 4 games is 6.25%, or 43.75% for at least 5 games. To help continue expanding this site, please don't forget to subscribe and like. Thanks for watching.